You need to copy, no need for the other diagram because syllabus is only pertaining to this diagram, statement, and the expression. No need for this and no need for this. Boys, are you able to see the angles clearly? Beta, alpha, and gamma? Are you able to see?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, fine. The next numerical based on this, I'll put the numerical, try to solve by yourself. Slightly you have to apply your mathematical concept. Boys?
Ma'am, the previous numerical that we did, we can solve with this equation, right?
The previous one, you can solve. You can solve. There is one more numerical, most probably let me put it in a worksheet because it often appears in your exam paper. If at all I'm going for an assignment, I'll just put that question. So you have to resolve all these vectors. We'll see that. Boys, you have copied or you need time to copy?
Ma'am, we need to copy.
Okay. Boys, over. Shall I move on to the next slide?
Yes, ma'am.
Now, 1 second, ma'am.
Shall I put it in this chat box, this slide?
Ma'am, can I take a screenshot?
Okay. Now, will you be able to do this? Will you be able to do this? Apply your Lamis theorem. I'll draw the diagram over here once again. Suppose if it is, this was P, this was Q. Was this correct, boys? What I have drawn in the previous one, P, Q, R. The order was correct?
Yes, ma'am, I was like this.
Okay, okay. This was alpha, this was beta, this was gamma. I'm just giving, so you have to shift yourself, apply this. P by sine alpha must be equal to Q by sine beta, which is equal to R by sine gamma. Now you have to, only thing is that you have to find alpha, beta, gamma. Will you be able to find alpha, beta, gamma? It's just mathematics. Once you find alpha, beta, gamma, then it will be easy for you to apply the Lamis theorem. You know this, suppose if I mark this as, okay, T2 is P. T2 takes the value of P. So this will be alpha, this will be beta, this will be gamma. Anyway, gamma, you can see it is 90 degrees. Only thing is that you have to find what is the value of alpha, what is the value of beta. Can you calculate beta mathematically? Anyone who has calculated beta?
Ma'am, is beta 120 degrees?
Beta is 120. Yes, correct.
And gamma is
How did you find beta as 120?
Ma'am, I drew a straight line at the point.
Okay.
And
Fine.
then the parallel lines
Okay.
and alternate angles.
You carry on. You carry on.
We can use transversal and find the
Yes. You
alpha and
can.
beta.
Fine. Yes. That's it's all up to you, boss. If anyone, someone is finding it difficult, I'll solve. Someone is finding it difficult, let me solve. Someone is finding it difficult to find this alpha, beta, gamma. Boys, can I move to the next slide? Have you taken this question? Shall I move for the next slide?
1 second.
Okay. Now, you know, how did you get 120 degrees? Austin?
Yes, ma'am.
Austin, you know how you got 120 degrees? Now, if not, shall I do for others also?
Oh, yes, ma'am.
Okay. Boys, I'll just go for this. So this angle was 90 degrees. Okay, this is 30 degrees. So what I'll do is I'll just draw a horizontal. When I'm drawing horizontal, now what happens to this angle? This angle is 90, correct? I'm dropping an horizontal over here like this. So this angle becomes 90. Okay, now let us go for this. So this is your transversal. If this is 30 degrees, then what about this? 30 degrees?
Yes, ma'am.
So 30 plus 90 comes to be
120.
same thing I have to apply for this side. So I'll take red marker. So this becomes 90, this angle. So if I draw,
And the other angle becomes 60.
yeah. This is your transversal. So this angle becomes 60. So 60 plus 90. 60 plus 90, that gives you 150. Is that clear, or anyone wants me to do it once again, or you're finding it fine, boys?
It's fine.
Yeah, or else I'll put a screenshot onto your chat box.
I didn't get it.
I'll do that one, sir.
Then apply the theorem. I think you can do this, boys. Then apply your theorem, boys. So T1 divided by sine 120 must be equal to T2 divided by sine 150. Now, how will I find this, boys? Trigonometric functions you have done? Boys, have you completed
Yes,
your trigonometry? Okay. Sine 120, I can write it as sine of 90 plus 60. Sorry, 90 plus 30. Correct? So sine of 90 plus 30 is cos 30.
Yes, ma'am. Which is
Yeah, so this
root 3
becomes
by 2.
cos 30. That is root 3 by 2. So And what about the sine 150? Sine 150 will be equal to sine of 90 plus 6g. So that is cos 6g. No, you can do your own. That becomes half. So this becomes cos 60 degrees. Sine 90 is 1. Cos.
So then what happened to 800?
Yes, boys.
Shouldn't it be 800?
800 Newton because 80 kilogram
No, I
into
got that, but then
yes.
in the file
No,
that's
no,
800.
yeah, you can use boys. Whichever way they're asking T1 by T2, so I can equate these two, right?
Okay. So you moved 800 by sine 90.
Yeah.
Okay, cool. Okay. Understood.
Okay. Once you have completed, boys, we'll start
So,
with
ma'am?
friction. What happened?
To find the value of T1 and T2, you have to use 800 by sine 90, right?
Yeah, you can.
Like to find the value, like here it's a ratio, but to find the value, you have to use the third equation. I
Yeah.
mean 800 by.
Correct.
Okay, ma'am.
Shall we move on to the next topic, friction, or you want me to wait? Eleven B. Once you have completed, just inform me that I need to go to the other one.
I'm done.
Done. Okay. We'll start with friction. Just write the subheading friction. Can someone read this? I'll call. Dheeraj is here or Dheeraj is absent?
Yes, ma'am, I'm here.
Okay. Dheeraj, just read out Dheeraj.
Is friction good or bad? Friction can be good. When we walk, we push backwards against the ground. The opposing force pushes us forward. Without friction, our feet would slip and walking would be impossible.
Okay, fine. Next. Continue, Dheeraj.
Friction is sometimes useful. Friction is useful for many of our daily activities. It is possible to hold a tumbler due to friction between the hand and the tumbler. Friction between the feet and ground helps us to walk on the ground. It is possible to write with a pen or pencil on a paper due to friction between the pen or pencil and the paper. It is possible to write on a blackboard due to friction between the chalk and blackboard. Friction between the tires and the road helps automobiles to move on roads, and friction between the bricks helps in the construction of buildings.
Good. Carry on. Carry on, Dheeraj.
Ma'am, I finished.
Dheeraj,
Okay.
you're good at English? You're good in English?
Yeah, I guess.
Yes.
I don't know.
Good. Carry on, Dheeraj.
Advantages and disadvantages of friction. Methods of reducing friction. Use of lubricants. Liquid lubricants, thin and thick oil, are used in machines to reduce friction.
Okay, one second, Dheeraj. Liquid lubricants, you very well know. Generally, we say this lube oil, which are used in automobiles. Cars, I'm asking you children, you are well versed than us. Cars, you use your lubricants. Do you often use your lubricants for cars?
Yes, ma'am.
Yes, ma'am.
Yes. Yes, you use. So many branded lubricants are available.
Yeah.
Many of you, right? Yeah.
Yes,
More
ma'am.
than us, you people know about it. Okay,
Oh,
now
yes,
look
ma'am.
at, okay, look at the solid lubricant. Now, solid lubricants, liquid lubricant generally in all machinery parts to stop the wear and tear or to minimize wear and tear, we use liquid lubricants. Solid lubricants generally we use a solid lubricant, what we call it as Veritis, right, which is an ore of aluminium, like it is aluminium sulfate. Aluminium sulfate is it's actually an ore of aluminium. Have you heard about onshore drilling and offshore drilling? This crude oil. Have you heard in this part of the world? You are here.
Yes,
You are
ma'am.
here in this part of the world. What is onshore drilling and what is offshore drilling? For crude oil.
Offshore drilling is basically in the middle of the ocean.
Okay.
Onshore
Onshore
is drilling on
on
land.
the shore. Yeah. So in some places, this crude oils is available onshore itself, but in some places it is somewhere deep inside. So you have to move well within the ocean. So when you are drilling for this crude oil, right, boys, deep inside the ocean bed, as the drilling equipment is being drilled, you use a lubricant. There should be a lubricant, and generally what we use the lubricant is what we call it as Veritis. It's an ore of aluminium sulfate, basically, any ore for that matter. Hematite, your iron is formed as a sulfide or a carbonate or an oxide, what it is. In hematite, hematite is one of the ore of iron. In what form? In what? Iron is in,
Solid.
no, iron is in solid. Do you know when iron is being extracted, how does your iron resemble solid state or liquid state? Was you're extracting iron from your ores, right? Generally, we do extract the
Liquid
Bessemer
state.
converter. Yes, yes,
Liquid because you melt it.
liquid. Iron, that's what iron is when it's being extracted. Iron is so soft, it flows like a liquid. That is why iron is always alloyed with carbon. You don't get pure form of your iron, Fe. It's always with carbon. Only the carbon, what you add, right? It makes your iron soft iron as well as wrought iron, WROUGHT. We call there are two types of iron. It's only how much percentage of carbon you are using, right? The hardness of iron depends on that, on it. The moment you extract iron from any of its ore, it will be so soft, it will flow like a liquid. Same way, aluminium sulfate is one of the compound found in Veritis. Generally, it is used for extracting aluminium. Now, Veritis, apart from using as a solid lubricant, they are used in paint industries also, right? So we do have solid lubricants. Then third one is in certain types of high-speed machinery, your film of gas that is between two machinery parts, instead of a liquid or the solid, they will have this film of gas at under high pressure has been used as lubricants. So these are the methods of reducing friction. So I think so the other initial part you children have been learning from grade 7 onwards, yes or no? Was you have learned all about your frictional forces, all these things you would have studied in your lower grades. Should I go for the preliminary ideas? No need, right? I'll start with the basic types of frictional force, what you are going to learn. Should I?
No, okay, ma'am.
Okay.
Yes, ma'am.
Okay, fine. Type of frictional forces. You have three types of frictional forces. One is static friction. Limiting friction belongs to static friction only because the maximum value a static friction can take is what we call it as limiting friction. So basically your frictional force, what we do is we divide it into static friction and dynamic friction, right? Under dynamic friction is that when See, for friction, there should be two bodies, right, in contact. So if I have a wooden block placed, if I have a wooden block, say, placed on a table surface, your frictional force when one object moves over the other, say the block is moving over the table, so now there will be a frictional force acting between the interface means the space between the block and the table. So always your frictional force is a tangential force. Your frictional force is a tangential force which is acting along the surface which divides both the object. Now, static friction is that frictional force when you suppose if you apply a force to move a block, you're pulling the block. Say the block is not moving, even though you have applied, the block is not moving, which means there is an equal amount of force which is acting in the opposite direction. So that applied force will get cancelled off. The body is still at rest. This is what we call it as static friction. The frictional force which comes into play the moment you apply a force on an object. You apply a force on an object, you're trying to pull the block. If the block is not moving, it means there is an equal amount force acting on in the opposite direction, which is stopping the motion of the object. That force which acts in the opposite direction called this as a frictional force, and specifically we call it as static friction. The static frictions can still be classified as limiting friction, that is the maximum value your static frictional force can take. Then dynamic friction. What is dynamic friction? When one object is moving over the other, say you're rolling an object on the floor, you would have seen as the object rolls, after some time the object comes to a rest, right? Why does it comes to a rest? Because of friction, it would have lost its energy. So as the object is moving over another surface, right, the object is in motion, but still it is experiencing a frictional force. Such frictional force, we call it as dynamic friction. There are two types of dynamic friction. One is sliding. Sliding means one object slides over the other, or there can be rolling friction, like your metal ball when it is rolling over the floor. Then in that case, we call it as rolling friction. You know what is sliding friction. So basically, your frictional force or friction is divided into two types: static friction as well as dynamic friction. So when an object moves over the other, when the object is in motion, it experiences a friction, and that friction is called dynamic friction. Okay. Can you copy down this, and then I'll go for the video presentation, right? Types of friction, static friction, and then dynamic friction. Under dynamic friction, you will have sliding friction and rolling friction.
So, ma'am, the friction an object experiences when it's not moving is static friction. The friction an object experiences when it's not in motion is called static friction.
Static friction. Yes, yes. We will deal with it in detail. I'm just starting with the introductory part. Sorry. Static and dynamic, under dynamic, sliding and rolling. I think I have few minutes. I'll go for a video clipping. Is that possible, boys? 10:55.
Ma'am?
Yes.
Ma'am, can you repeat what's static friction?
No, I have to teach static.
Okay, ma'am.
So how many minutes left, boys? Because if I start the video, it's 2 minutes, right? Okay, anyway, you can. Boys, please try to upload your holiday homework. I'm just asking only that art integrated, that we have asked to browse. You can browse your net and select a natural phenomenon and explain it based on physics as well as the other subjects which you learn. Do you understand what I'm talking about?
Yes, ma'am.
Yeah.
Yes, ma'am.
I have created a folder in your physics file section. Please upload it. The worksheet and the question paper, we will discuss it in the next coming up week. But this one, please upload it so that we have to take assess that and we have to take the marks for that. Now, these are all your evidences. In case CBSE is very particular in asking evidence. So if at all for internal assessment, when we give marks for you, when we assign marks for individual students, they'll ask for on what basis it is being assessed. So that's the reason. So please don't delay in uploading. By the end of this Thursday, will you be able to upload, boys? 11B?
Yes, ma'am.
Thursday, just upload it. If you can't take a picture, you can browse your net, take any concept, might be formation of rainbow or whatever it is, any physical, natural phenomenon. Or in case if you want to go beyond that also, no problem. Whichever fascinates you, any physical phenomenon related to physics, just put it. Okay. You can leave. I think so. I'll start with next two periods are there. So lots of video clipping I have to show for this chapter because initial part is conceptual. Once the conceptual part is clear, then we'll start with derivation and numerical. Thank you, boss.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.